Here's an offshore wind turbine park. Can anybody guess how much one wind turbine weighs? It's 475 tons, an equivalent of 7,500 people. A good festival. Every ton adds cost in transportation, production, materials, so it would be nice to drop some of them off. But there's a reason why wind turbines have to weigh so much. That not only the rotors are very huge and heavy, but also the environmental conditions are very aggressive. Whoops. Here's an example of the Tahoma Narrows Bridge under wind loading. Seemingly out of nowhere, these resonant vibrations start happening, causing the bridge to collapse. So if the environmental conditions are capable of causing this damage to a bridge, what would happen to a poor offshore wind turbine? And how knowing that would help to reduce the weight of offshore wind turbines and hence make them more attractive for investment by reducing the price. My name is Agota Mockutė, and yes, I'm a second-year PhD student at the University of Birmingham with the Owls for Future project. And my research is on offshore wind turbine modeling, in particular the wave loading and how it makes the turbines sway. The offshore conditions allow for steadier and stronger winds. Therefore, the wind turbines can be much larger, generating more electricity per turbine. For example, the largest currently implemented wind turbine, Vestas V164, for 8 megawatts, just one rotation at the rated perfect speed generates enough electricity to power an average house for 29 hours, and it currently holds the world record for the most electricity produced in 24 hours from one wind turbine, which was enough to power a small village just off the coast. Overall, wind energy is booming. For example, in 2015, Denmark has beaten its own record by generating over 42% of its consumption for the whole year just from wind resources. The other leaders of the field are also doing well. So wind technology is proving to be successful. It reduces the necessity for fossil fuels and helps the countries to meet the renewable targets. Nonetheless, there seems to be a trend that the international government funding for the wind turbines is decreasing. It's just costing too much for the taxpayers. Denmark and Germany are paying the most tax for electricity. But onshore wind energy seems to have settled fine, and it is as competitive with fossil fuels as it has never been before. The wind turbine prices have been dropping since 2008, and in years 2015 and 16, the new offshore wind turbine installation has been the largest so far. Offshore wind, however, represents only 3% of the global capacity, and it's still a very expensive technology. Therefore, for it to enter the market without the support might be a little tough. And I don't know about you, but I really like this technology, and I think it provides beautiful opportunity to collect the resources without annoying the people too much by placing the wind turbines in their backyards. So I'm now on a mission to do what I can as a civil engineer to reduce the cost of offshore wind turbines. The design process can be simplified to firstly estimating the loads, mainly wind, waves, and current, for the location of interest, and then designing the wind turbine to withstand those loads. But the higher the loads, the bigger, stronger the structure has to be, the more material has to be implemented in it, and the higher the cost happens. So it would be all good and nice if we knew the loads accurately. However, there are many uncertainties in the modeling, which, to be on the safe side so that the wind turbine doesn't collapse because we didn't take some little thing into account, the design loads are calculated as a higher value. So this, in the end, increases the cost because loads are higher and the structure is bigger. Reducing the uncertainties would reduce the cost. Therefore, so why wouldn't we just take the most developed models that we have and calculate the loads as accurately as we can? But the problem is that the accurate models take a long time the design process is very costly and time restrained when you work in a company. Therefore, even though technology allows for fantastic models of real environmental conditions, these simulations take a very long time and are costly. Therefore, much simplified wave theories are used in the industrial solvers. So coming back to the Homo bridge, these oscillations are a case of resonance. The frequency of the storm matched the natural frequency of the bridge, causing the structure to sway. The same principle as pushing someone on the swing. Therefore, now engineers have learned, and the structures are designed at a higher frequency than the expected loads around, for example, wind in this case. But so how about wind turbines? If we do design them at a higher natural frequency than the wave loads that affect them, what is the problem? The issue is that the sea has not a single frequency, but a range. So normally the other frequencies don't have enough energy to trigger any oscillations. But if a particularly steep wave passes by a wind turbine, a higher values, oh, sorry, don't know what happened. Oh. So when a steep wave passes by, and it can trigger higher order resonance phenomena, causing these unexpected wind loads. So that's how a wind turbine would resonate. These continuous large oscillations cause fatigue loads on the turbine, increasing the loads, and sorry. The structure gets tired and it reduces its lifetime and increases the loads. The problem is that with the simplified waves that we've seen before, these oscillations, the higher nonlinear ones, are omitted. They're simply not seen. Therefore, more inaccuracies are noted. But just having the wave motion is not enough to assess the load on the turbines. When the waves hit the turbine, there are hydrodynamic models are needed to convert the velocities into forces. And yet again, there are different ones of increasing complexity. And again, just the simplest one is implemented in all the commercial models, even though scientists do agree that in more complex conditions where nonlinear effects happen, these might be insufficient. Therefore, in my PhD, I am modeling the fully nonlinear waves and comparing the different hydrodynamic models to assess which one's the most suited to investigate the resonating phenomena, and hoping that this would decrease the cost of wind turbines, making them more competitive. Thank you.
Thank you very much, Agota. Now, have we got any questions for Agota based on her speech that we've just heard? Lady in the red, full of questions this morning.
First of all, I would like to tell you, don't worry, it was fine, okay? So, secondly, the models that you are investigating are more suitable, I suppose, for the Baltics rather than other seas. Does it depend on the depth of the seas, and how does that have any influence on the work that you're doing? Thank you.
Thank you for the question. Yes, it depends on the depth of the seas, but monopile wind turbines, the monopile supported, just sticked into the ground, are usually implemented to the depths no deeper than 30. The optimal depth is 30 meters. So it doesn't depend on the actual sea as much as the bed. In Mediterranean, yes, it's true, it slopes down much faster, but there are some places on the shore where monopile offshore wind turbines would be still cost effective. And if it's a monopile, if it's just one cylinder, then the load calculations are the same as described.
Thank you. Any other questions? You have another one? Oh, okay.
Well, actually, I'm interested in this technology, let's say, because in my country, I'm from Greece, there is a lot of resistance in turbines because of environmental problems, and that they are reporting that there are birds are influenced, etc. And so everybody is against them. So have you anything to say about this, and whether scientific research can say more on why we can use them and they don't have any environmental impact? Thank you.
Thank you. So as for birds, the statistics are that wind turbines do contribute to killing the birds, but it's 0.01%. Much higher influence is by pesticides, cats, traffic, but the largest one is buildings. Just below 50% of birds die when they hit tall structures with windows. So I do disagree. I think it's a myth that offshore wind turbines are just serial bird killers. As for the sea fauna, when wind turbines are installed, there's much technology how to prevent the effect on birds. So for example, when a monopile structure is drilled into the ground, there's a lot of shock, but there are these beautiful things called bubble curtains. When a radius around the turbine is covered with these structures that produce the bubbles, which absorb all of the excitation that comes from this. So research is still being done how to prevent effect on the environment, but I do believe that it shouldn't be the main reason not to invest.
Okay, thank you very much.